As I mentioned before, regarding that these plants already have loads of data on their production lines, but many of them are not they're not being optimized, they're not being fully utilized. So what Deep Meta does is that we capture all the data on the production line, and we use machine learning to basically create a classification system of products which are defective and those which are non-defective, and we are then learning the processes and that are associated with a successful event, i.e., a product that was done well, and those which are not done well. And then based upon that, we then make future predictions off of a current run of on the mill, if that's going to be defective or not. If it is going to be defective, what you need to change in order to avoid that.
This is the bit that I've struggled to understand in the past, because to me, to the untrained layman in the street, steel is steel is steel, and I would have thought that they'd kind of finely tuned their assembly line to produce perfect steel every time. So how is it that the settings on the assembly line are changing from run to run?
So the assembly line settings always change because you have different kinds of products that are made on the steel plant. So, for example, you can have different dimensions. If you're going to be making products like rod, then you might have some that are 17 mil, some that are 10 mil, some that are 5 mil. And depending on what product it is, you're going to be changing the different dimensions on the mill. But when you go between, say, 5 and 17 and then 12 and back to 5 again, it's never going to be exactly the same. So that's just one example of something that on the line that is dynamic and difficult to replicate. And so it's difficult for the operators to be able to actually identify what will be the most optimum position for that product. Second thing is that there are differences in the actual composition of the steel, and different compositions of steel behave in dissimilar ways. What I mean is you've got some steels that are a bit harder, some that are a bit softer, and so the way that they're going to be interacting with the machinery, it differs. Machinery itself changes over time. So you've got some rolls that can become harder. That's due to something called work hardening, just because they are pressing the steel together to make it form into a certain kind of shape that will be ideal. It also affects the tooling, and so it's a dynamic process that you can't just have a fixed setting for it and it will work every single time. There are these nuances that need to be taken into consideration when you are thinking about what's going to be the most optimum setup for me at this point in time. And because of that change, and that's what makes things like deep meta useful, because what it does, it basically learns from historic knowledge, and people on the production line, they're incredibly knowledgeable, highly skilled, and we're going to be capitalizing on the data that they've collected so far and their expertise to be able to inform their future decisions.
Yeah, nice. I've seen similar things happen in kind of medicine and in law, where you've got a bunch of human experts, where the kind of I suppose the principle is decisions made by humans but informed by machines, where you've got an AI that's, or a machine learning model that's looking at all of the available parameters and then making a comment that the humans then look at, and that informs, okay, so there's something we didn't think about, and together they make something which is better than either making the decisions by themselves. Is that something similar to what you're doing?
I think that's a pretty good. It's a good way of explaining it. I think that's a reasonable analogy. And as you say, it's not just in steel production or in medicine, but actually it's likely going to be in increasingly different parts of society and aiding decision making, because we've got so much data out there, and this is kind of the double-edged sword of big data, if you like, in that you've got loads out there, which is great because it's given us new ways to inform our decision making. But human beings were not designed to like crunch huge amounts of data. We are designed to make nuanced decisions based upon like things that might be hard to detect by current machines anyway. But handling all that data, it's not what we're made for. And so a marriage between these two kinds of performances is going to be really critical going forward in the future in various industries.